All right, today we're looking at two concepts. One is called estimating square roots, and the other is labeling things like square roots as irrational numbers. So we're going to look at these two concepts. As we see before us, we see the number 29, square root of 29. 29, of course, is not a perfect square. And so to solve this problem, at this stage in our understanding of square roots, what we want to do is not so much find the exact value, the extremely long decimal of what it is, but instead to figure out what two consecutive numbers does this square root fit in between. And so to do this, what you're going to do is you're going to use your knowledge of squares to help you solve this problem. So, for example, we know that 2 times 2 squared equals 4, and so that means the square root of 4 equals 2. Okay? And so there are different numbers that we know you should have through, my opinion is 20 memorized, knowing your squares. So 20 squared and downward, being able to do that rather quickly. And that would help you out greatly. Today, let's use this concept then to look at our square root of 29. Square root of 29, we want to use numbers that we know, right? And so I can start with a number like 25. I know that the square root of 25 equals 5. And my other perfect square that I can easily identify is the square root of 36, which is 6. Now, because I'm between 25 and 36, I know that this 29 fits here. And so I could say that the square root of 29 is somewhere between 5 and 6. So these are the two consecutive numbers that fit into this problem, right? Let's try this one. It says, between which two square roots is the square root of 200? Right? Once we get kind of past our known ones, right, our 2 times 2 and our 3 times 3, 5 times 5, 6 times 6, 9 times 9, those are the ones you've been memorizing since 3rd grade. But here, now we're looking at that idea and we're saying, okay, now we're in the 200s. And we're dealing with numbers that maybe aren't as familiar. So where do we start? We start with things that we know. Right? I know that 10 squared equals 100, and if I go to my highest degree, I would say 20 squared equals 400. So right in there, I know I have to go somewhere in between these to get to that 200 mark. Now, because it's 200, I'm going to probably go a little bit lower, right? And one place to start is maybe possibly in the middle. Right? One place to start is in the middle. So if I say 15 squared, right? 15 squared is equal to 225. And here now I'm pretty close to my 200. Right? And from here, since I found a number that is very similar, I can decide if I'm going to go up or down accordingly. You know, I could do 12 next if I wanted to, because that one is one that's memorized. That's 144. Okay, so now I've narrowed it down between 12 and 15. And in the end, we're going to come away with an answer of 14, because 14 times 14 is 196. And so in the end, we see that 200, square root of 200, fits in between 14 and 15. So there's that guess and check kind of method. But like I said, if you have these squares memorized up through 20, you get a very good understanding of the numbers. All right. Now on top of this, we're throwing in this idea. It's called an irrational numbers. A number of lessons ago, as we just talk about numbers, we talk about the fact that you have, we had a diagram that kind of looked like this, right? Where we had our whole numbers, and then we had our integers, and then we had our rational numbers. And today we want to add in one more column like this, and this is what we call irrational numbers, right? And irrational numbers are a number that cannot be expressed as a ratio of 2 integers. So that's what kind of makes them special, is they get this unique identification of what's going on. So what does this look like? What does this? When it comes to these irrational numbers, we end up looking for numbers that just don't really make a lot of sense, that are easily solved, right? And so examples of those are going to be things like square roots. They're going to be things like repeating decimals. Right? Those numbers are hard to express and hard to identify because of the unique nature of their ideas. There's other numbers that exist out there too, right? Like this number here, right, represented by symbols. And so as you look at these different things, these things can fit into irrational numbers. Now, while irrational numbers are kind of hard to pinpoint exactly what they're equal to, they still can be placed in approximate places on a number line. So this is your sample. It says draw a number line and show the approximate location of the points representing the following real numbers. Right? A real number is a number that basically is, what am I trying to say? Well, it's not an imaginary number. It's not a made-up number. That's what makes it real. Real numbers are made up of rational numbers and irrational numbers. So all numbers combined that fit into those categories would be considered real numbers. All right, that's our definition. All right, graph these. Graph these. Okay? And then label these numbers either as rational or irrational. All right, that's it for lesson 100.